Yesterday, we discovered where the internet lives, inside buildings that never sleep. But today, those buildings don't matter, because before your request can reach a single server, it must answer one question: where should I go? Your computer doesn't know. Your phone doesn't know. Even your router doesn't know. So who does? Without that answer, the internet would never begin.
Humans love names. We remember faces, places, words, stories. Machines don't. Computers understand something far simpler: numbers. Every website you've ever visited has one. Not a brand name, not a logo, an address, a numerical identity, invisible to almost everyone, necessary for every machine. When you type a familiar website, your device quietly translates your intention into a question. I'm looking for this destination. Can someone tell me where it actually is? That question travels into one of the oldest and most important systems ever built for the internet. Imagine a city with millions of buildings. Every house exists. Every office exists. Every hospital exists. But none of them have an address. No street names, no house numbers, no postal codes. Now imagine asking someone to deliver a package. Where would it go? It couldn't. Not because the city doesn't exist, but because nothing can be located. The internet faces exactly the same challenge. Billions of destinations exist. But before information can travel, every destination must first be identified. Without an address, even the fastest network becomes completely useless.
This is where the internet reveals one of its biggest secrets. The names you recognize are not the names computers use. To a machine, every famous website, every online store, every streaming platform, every search engine is simply another number. So somewhere between the name you type and the website you expect, someone has to perform the translation.
That translator is DNS, the Domain Name System, often described as the internet's phone book. But today, that comparison barely captures its importance. A phone book waits until someone opens it. DNS never waits. It answers requests continuously, every second, from every continent, for billions of devices, quietly connecting people to the places they're trying to reach. The remarkable part isn't that DNS knows every address. It's that it can find the right one almost instantly, so quickly that most people never realize a search even happened.
Finding one address isn't always one conversation. Sometimes it's several. Your device asks a nearby DNS resolver. If the answer already exists, the journey ends immediately. If not, another question is asked, then another. Across specialized DNS systems, each responsible for only one piece of the puzzle. No single server knows everything. Instead, each one contributes a small piece of information. Together, they produce one complete answer. It's another example of how the internet solves enormous problems, not with one gigantic machine, but with countless specialized systems cooperating perfectly.
Now imagine DNS suddenly disappears. The websites still exist, The servers still operate. The data centers continue running. The fiber optic cables remain connected. Nothing has physically broken. And yet, almost everything stops because nobody knows where anything is anymore. The internet hasn't disappeared. It has simply lost its map. And that reveals something extraordinary. Sometimes, the most important system isn't the biggest one. It's the one that quietly helps every other system find its way.
One of the most remarkable things about DNS is how quickly it disappears. Not because it stops working, because it finishes its job before you notice it exists. From the moment you press enter, the clock begins ticking. Milliseconds matter. Every unnecessary delay makes the internet feel slower. So DNS was designed to answer questions with extraordinary efficiency. Not once a day, not once a minute, billions of times every single day. Around the world, without applause, without recognition, without most people ever knowing its name.
Now imagine asking someone for the same address every 5 seconds. It would waste time, so computers learned to remember. When a DNS answer is received, it isn't always forgotten immediately. For a limited period, it can be stored locally, ready for the next request. This process is called caching, a simple idea with enormous impact. Instead of asking the same question again, your device simply remembers the answer. Fewer requests, less waiting, faster browsing. Sometimes the fastest journey is the one you don't need to repeat.
People often imagine there must be one giant computer controlling the entire internet. There isn't. DNS doesn't depend on one building, one company, or one machine. It is distributed. Responsibility is shared. Knowledge is divided. Thousands of servers cooperate together, each performing a specific role. If one disappears, others continue working. Not because failure is impossible, but because resilience was part of the design from the beginning. The internet isn't powerful because everything is centralized. It's powerful because almost nothing is.
Here's the twist. DNS never delivers the website you're looking for. It never sends the web page. It never loads the images. It never plays the video. DNS does only one thing. It answers one question. Where? That's all. And somehow, that single answer unlocks everything else. Sometimes, the smallest responsibility creates the biggest impact. Because once your device knows the destination, the real journey can finally begin.
DNS answered the question. The destination is known. But another mystery immediately appears. Knowing an address doesn't move information. Someone still has to deliver it. Across neighborhoods, across countries, across oceans. Choosing the fastest path, avoiding congestion, recovering from failure, making billions of tiny decisions every single second.
And that's where another invisible system quietly takes over. A system most people use every day without ever realizing it exists.
Imagine writing one wrong house number. The street is correct. The city is correct. Everything looks normal, except one number. Your package arrives somewhere else. The internet works the same way. One incorrect address can send a request to the wrong destination. That is why accuracy matters, not just speed. Every translation must be correct. Every response must be trusted. Because billions of people make decisions based on where DNS tells them to go. One tiny mistake can become millions of wrong turns.
DNS isn't only used when you open a website. Your phone uses it. Your smart television uses it. Cloud applications use it. Video games use it. Streaming platforms use it. Smart speakers use it. Security cameras use it. Even many connected vehicles depend on it. Every connected device must answer the same question. Where is the service I'm trying to reach? The question changes, the destination changes, the device changes, but the process remains the same. Find the address, then begin the journey, again and again, billions of times every day.
When people think about the internet, they often imagine speed, fiber optics, powerful processors, artificial intelligence, massive data centers. But before any of those systems matter, something much simpler must happen first. A destination must be trusted. Every connection begins with confidence. Confidence that the address is correct. Confidence that the response is authentic. Confidence that your request is traveling where you intended it to go. Without trust, speed becomes meaningless, because arriving quickly at the wrong destination is still failure.
Every successful digital platform begins with the right architecture, reliable foundations, scalable applications, well-structured interfaces, reusable components, secure authentication, efficient administration. Modern development teams rarely reinvent these foundations. Instead, they build on proven systems, allowing them to focus on solving real problems. If you'd like to explore production-ready templates, admin dashboards, UI frameworks, and developer resources inspired by today's software industry, you'll find a curated collection in the description below.
Today, we discovered how the internet finds its destination. But knowing where to go is only the beginning. The next mystery is even more fascinating. How does information actually travel across continents in less than a second? How can billions of requests share the same infrastructure without colliding? And who decides which path is the fastest? Those answers are waiting in our next investigation. Every website, every application, every cloud service, every connected device begins exactly the same way, with a question. Not, can I connect? But, where should I go? That single question quietly activates one of the oldest and most essential systems ever created for the internet. A system so reliable that billions of people depend on it without ever learning its name. Perhaps that's the greatest achievement of modern technology. The systems that matter most are often the ones we never notice. This is NextNet, not just explaining the internet, revealing the invisible systems that quietly shape our digital civilization. Next time, we'll follow your data after DNS has answered, across routers, across fiber optics, across oceans, to discover how the internet chooses the fastest path home.